So more Venn diagrams and probabilities, conditional probabilities in particular. Let's see how you get on with this one. Okay, so I'm going to draw a Venn diagram. That's what the question asks us to do, Venn diagram to show this information. Before I actually put pen to paper, the thing that stands out is that events A and C are mutually exclusive. We've got three events, A, B, and C, so we might naturally draw them in this way, A, B, and C, all overlapping. But we're told that A and C are mutually exclusive, so this bit, there's no overlap. There shouldn't be an overlap between A and C. So we can make our Venn diagram a little bit clearer by doing that. We make sure that there's no overlap between A and C, but there is an overlap between A and B and an overlap between B and C. Okay, so let's have a look at some of the numbers. We're told that A or B or C is 0.9, so that's all of that. The probability of all of that happening is 0.9, so therefore the bit around the outside must be 0.1. Okay, so we're told now that the probability of C is 0.3 and the probability of B given C is 1 over 6. So we can use this formula here to calculate the probability of C and B. So the probability of C and B is 0.05, and that's this sector here. And then because the probability of C on its own is 0.3, this bit here must be 0.25 because the probability of C adds up to 0.3. And then A and not B is 0.35, that's this sector here. And B and not C and not A is 0.15. So that's B, but not C and not A. That's that bit in the middle there. So that's 0.15. And then we can fill this last number in by subtracting all of those other numbers from 1. So those should all add up to 1. Let's just have a check. 5, 6, 7, 8, 9, 10. That's fine. That's all adds up to 1. Okay, so part B now. Determine whether B and C, the events B and C, are independent. There are two ways to do that. The first one is to compare the probability of B with the probability of B given C. And if they're the same, then B and C are independent. If not, then not. And so they're not independent. The other way is to compare the probability of B times the probability of C with the probability of B and C. And you can see they're different to each other. B and C are not independent. Okay, so part C of the question now. Find the probability of C given not B. And there's the formula for the probability of C given not B. And when we pop the numbers in to the formula, we get 5 over 14. And finally, D, the probability of A, which is that, or B and not C. Well, B and not C is that. So the probability of those sectors is those three numbers together, 0.35, 0.1 and 0.15, so that's 0.6 altogether. So there we are, probability.